we are going to be modeling a linear function using our graphing calculators. When given a set of paired data, you can use a scatter plot to see the data, whether the data shows a linear trend. If so, you can use a graphing calculator to perform linear regression and obtain a linear function that models the data. You should treat the least and greatest x values of the data as the boundaries of the domain of the linear model. When you perform linear regression, a graphing calculator will report the value of the correlation coefficient, which is known as the variable R. This variable can have a value from -1 to +1. It measures the direction and strength of the relationship between the variables x and y. If the value of r is negative, the y values tend to decrease as the x values increase. If the value of r is positive, the y values tend to increase and the x values increase. The more linear the relationship between x and y is, the closer the value of r is to -1 or +1. Okay. Now, these are the values we look for to determine strength of correlation if it's closer to -1 or +1. So it could be in either direction. You can use the linear model to make predictions and decisions based on the data. Making a prediction within the domain of the linear model is called interpolation. Making a prediction outside of the domain is called extrapolation. Now, these directions are to perform linear regression using a graphing calculator. Okay? First of all, you're going to create a scatter plot of the data by entering the data into list 1, which is your x values, and list 2, which are your y values. Okay? Remember, you are given coordinate points x and y for your data. Your x values are all going to go into list 1. Your y values will go into list 2. You will then create a scatter plot of the data. You go second, stat plot, and make sure to highlight on. Remember, you can select your different graph types. We are working with a scatter plot. So look for the graph that has the little dots. That is indicative of your scatter plot. You will then press the zoom window to data only, which is zoom stat, I believe on your calculators. That is number 9 if you scroll down. To perform linear regression, you will write the model and its domain. So the model is going to be very familiar to you. It is simply y equals ax plus b. Very similar to slope-intercept form, except we use an a instead of m for slope. A is still indicative of the slope, and b is still your y-intercept. The domain is the minimum to maximum x values. So according to your data, that is how we set the domain. You're going to graph the model along with the data to obtain a visual check on the goodness of fit, and you will enter the linear regression as y equals into the graphing window, which is just when you press y equals. Okay, you will see a window where you have y1, y's of 2, y's of 3, and so on and so forth. You are going to enter your regression formula into the first one. So this is where you would type in ax plus b. And then you will graph the model by hitting the graph button and make a prediction based on the data in linear regression. Now, I understand that it is difficult to understand how to do this without actually seeing it done. So we're going to use A to perform linear regression, but before we get to the calculator part, let's go ahead and read through the problem and identify our domain and range and what it all means. Okay, so for A, it says a photographer hiked through the Grand Canyon. Each day, she stored photos on a memory card for her digital camera. When she returned from the trip, she deleted some photos from each memory card, saving only the best. The table shows the number of photos she kept from all of those stored on each memory card. Use a graphing calculator to create a scatter plot of the data, find a linear regression model, and graph the model. Then use the model to predict the number of photos the photographer will keep if she takes 150 photos. So you can see here in the table, we're talking about the pictures taken at the Grand Canyon. These are the photos taken and these are the photos kept. Okay, the first thing you need to do is determine what is your dependent and independent variables, right? So does the photos taken depend on the photos kept, or do the photos kept depend on the photos taken? So let's start with X, our independent variable, okay? So when you think about it, what was your selection? Do photos taken depend on photos kept, or do photos kept depend on photos taken? If you answered that photos taken is your independent variable, then you are correct, right? Because the photos kept would be the dependent on the photos taken. So dependent and independent, my X is the number of photos taken, which will go into your calculator, into your list as list 1. And our Y variable is the number of photos kept, which will go into your list 2. And I will walk you through all of this, okay? All right, so now that we've determined our domain and range, right? X is domain, Y is range. Let's go ahead and look at the calculator use.
Let's look at how to use the calculator in order to perform linear regression. First thing we want to do is get to the table. If you remember, stat and edit is where your table will pop up. L1 means list 1, L2 is list 2, and so on and so forth. If you already have something in your list, remember, do not press delete. You can simply scroll up, hit the clear button, and press enter. And that's going to clear your entire list. Okay, now looking at the data from the Grand Canyon pictures, okay, if you guys can see that there, I'm going to use this data to input into the calculator. So we already determined that the photos taken were the independent variable and the photos kept was the dependent variable. So these are the values we are going to input into each of our lists. Okay, now how we do this is I am going to input the X values first. So under list 1, trying my best to have you guys see both here. Under list 1, we're going to type in 117, that's the very first number up here at the top, and press enter. And you can see that it continues downwards. So I'm going to type in all of my X values first. Next one is 128, 140, 157, 110, 188, and 170. Okay, once you have finished typing up all of the X values, and you guys can see that here, those are the only X values, I am now going to move on to the Y values. And in order to do that, we have to scroll over to list 2. So I'm going to go in order because remember, these are coordinate points that have to line up. So I'm going to start with 25, 31, 39, 52, 21, 45, and 42. Okay, so when you type your last number, you guys can see these dotted lines down at the bottom. They should be equal, right? So if I scroll up, 110 aligns with 21. And I can see here, 110 lines up with 21. That should be the same process in your calculator. Once you have finished typing up your list, you are then going to go into your scatter plot. So I'm going to go second, stat plot. And you guys can see that it's already turned on, but it's turned on to a box and whisker plot. So I'm going to hit enter and scroll down into the scatter plot. You can see, and I know it's hard to see here, but you can see the little graph. It has points. That's what's going to give us a scatter plot. I highlighted it, and you can see that my list is very specific. X list correlates to list 1, Y list correlates to list 2. Okay. Once this is on, you are going to hit zoom stat. So the zoom button is up here. Oops. Second, quit, zoom, and scroll down to zoom stat, which is number 9. Hit enter, and there's my scatter plot. Okay, this is the information, or this is what we want to see. Now, from the shape of it, you can see that it is somewhat linear. I could draw a straight line through it, right? And it would cover most of the points, if not half the points around it. To perform regression, we are going to hit the stat button, scroll over to calculate, and scroll down to linear regression, which is number 4. Now, if you continue scrolling, there is a second one, but notice that our formula is different. We do not want this one. We use number 4, AX plus B. Hit enter. List 1 is X, list 2 is Y. Hit enter all the way down to calculate, and you get these 3 values. Okay, you can see our equation, Y equals AX plus B. You can see the value of A, which would be the slope, and you can see the value of B, which would be our y-intercept. Now, we are missing the correlation coefficient, so we have to turn that on. If your calculator already gave you the R value, that's great. If not, what you want to do is go down to the catalog. So you're going to hit second 0 for catalog, and it's going to bring you up to this. Okay, what you want to do is you want to scroll down to diagnostic on. So it is in alphabetical order. You're looking for diagnostic on. You're going to press enter and enter again, and this is confirming that your diagnostic tool is now on. We're going to repeat the stat, calculate, for, or linear regression, and now it is giving us the extra R values, okay? R is our correlation coefficient. This is the value we are looking for. We're going to take A and B and the R value and use them to come up with our regression equation. And we're going to use the R value to predict strength.
Okay, from the previous segment, we saw how to calculate regression. And if you still have your calculator, we are simply copying down those values. So for A, we had a value of 0.33. B gave us a value of negative 11.326. Let's extend it one more. So A is 0.331 rounded, B is 11.326. Okay, so putting these together, our regression line is y equals 0.33x minus 11.33. Okay. Now, our domain. Let's define our domain because we are going to graph this along with the data. The domain of the data is based on the minimum and maximum x values. So if we go back to our table, this is our minimum value, right? And our maximum value is 188, smallest and largest. So our domain is going to range from 110 up to 188. Next step, you are going to graph the model along with the data and then use that to make a prediction. So let's go ahead and continue by graphing this in our calculators.
So to graph this, we already have this information and we wrote it down on our papers. This is the equation we're going to use. you simply go to the graphing tool, which is y equals, and you can see our stat plot is on, right? Our scatter plot is on. We are going to type in our equation here. So in this case, we have 0.33x, so 0.33, and this is our x value right here, minus 331x, minus 11.326, okay? And in order to graph this, all we have to do, or to graph the line, is just hit the graph button. Our scatter plot is already there, and there is our linear regression. Now, as you can see, it does cross one point. Ideally, we would want it to cross more than one point, but you can see how our data is centered around that line, okay? And if we go back and look at our regression value, our correlation coefficient R was 0.84. I would say that is a pretty strong relationship. It's not as close to 1. So when you think about the directions of correlation, -1 to +1, 0 would be no relationship. 0.5 would be, there's some relationship. 0.85 is fairly close to 1. So we could say that this is a strong relationship.
Now that we have seen how to graph our model, we can go ahead and make a prediction, okay? So it says predict the number of photos this photographer will keep if she takes 150 photos. That means we are going to substitute 150 in for x. Okay, we have our model, y equals 0.331 times 150 minus 11.33. Plug that into your calculator, and you get about 38 pictures. Now remember, this is one of those questions where you have to think about decimals being appropriate or not. Can you have 0.7 of a picture? No. Okay, so we do round it to 38 pictures. According to this model, she will keep about 38 photos if she takes 150 photos.